February 22nd, 1943. Near Spitla, Tunisia. The dust was still settling from the fierce tank battle when Panzerabteilung 501 discovered what would become the most important intelligence find of the North African campaign. Sitting abandoned beside a burning American half-track was an intact M4A1 Sherman tank, its name War Daddy 2 painted in white letters across the olive-drab hull. The German tank crew that climbed inside this captured enemy vehicle was about to discover something that would fundamentally challenge everything they thought they knew about armored warfare. 4 days and 350 kilometers later, War Daddy 2 arrived at the port of Tunis, ready for shipment to Germany. The Sherman would soon undergo the most comprehensive testing any American tank had received at enemy hands. At the Kummersdorf proving grounds outside Berlin, German engineers would discover that their assumptions about American tank design were completely wrong. They expected to find a crude, poorly built machine that reflected American industrial inexperience. Instead, they found an automotive masterpiece that revealed the true secret of American armored warfare. Reliability was deadlier than armor. This is the story of how German tank crews, testing captured Sherman tanks throughout World War II, gradually realized that the Americans had revolutionized armored warfare not through superior firepower or thicker armor, but through mechanical reliability that kept tanks fighting when German panzers broke down. The Germans discovered that a tank that could be repaired in minutes was more valuable than one that could survive direct hits, but spent weeks in the workshop. By the time they understood this lesson, it was too late. When War Daddy 2 reached Kummersdorf in March 1943, German tank designers were confident in their technological superiority. Their Panzer III and Panzer IV tanks featured sophisticated engineering that emphasized precision manufacturing and complex mechanical systems. German tank doctrine prioritized individual vehicle superiority, assuming that better engineered tanks would defeat numerically superior but technically inferior enemies. The testing of the captured Sherman would challenge these fundamental assumptions. The initial examination revealed construction methods that shocked German engineers. Where German tanks used precision machined components requiring specialized tools and lengthy manufacturing processes, the Sherman employed simple, interchangeable parts that could be mass-produced by factories with minimal retooling. The transmission was mounted in the front of the hull, accessible through removable panels that allowed complete replacement in the field. German engineers had never seen such emphasis on maintenance accessibility in a combat vehicle. Obergefreiter Klaus Weber, assigned to the Sherman testing program, later wrote in his diary about the first time he drove the captured American tank. The smooth operation of the transmission amazed him, particularly compared to the temperamental gearboxes of German tanks that required careful handling and frequent adjustment. The Sherman's synchronized transmission allowed gear changes without double clutching, a luxury that German tank drivers could only dream of experiencing in their own vehicles. The engine bay revealed even more surprises. The Sherman's Continental R975 radial engine was designed for ease of maintenance, with spark plugs, oil filters, and other service items easily accessible without removing major components. German tank engines required extensive disassembly for routine maintenance, often keeping vehicles out of action for days, while mechanics performed relatively simple tasks. The American approach prioritized operational availability over engineering elegance. German test drivers discovered that the Sherman's rubber-padded tracks provided remarkably smooth operation compared to the steel tracks used on German tanks. The rubber pads reduced wear on both tracks and road wheels, while providing better traction on paved surfaces. More importantly, the tracks could be repaired quickly using simple tools and replacement pads that were interchangeable across the entire track system. German tank tracks required specialized tools and skilled mechanics for field repairs. The testing revealed the Sherman's most revolutionary feature: standardized components that allowed rapid field maintenance. The suspension used standardized bolts that could be removed with common tools, allowing complete bogie replacement in under an hour. German tank suspension systems required specialized equipment and factory-trained mechanics for major repairs. The difference in maintenance philosophy represented fundamentally different approaches to armored warfare. Captain Heinrich Müller, the Wehrmacht's chief automotive engineer at Kummersdorf, supervised extensive reliability testing of the captured Sherman. His report, filed in June 1943, concluded that American tank design prioritized operational readiness over individual vehicle performance. Müller noted that while German tanks possessed superior armor and firepower, the Sherman's mechanical reliability provided strategic advantages that German designers had failed to consider. The testing program expanded, as more captured Shermans arrived at German proving grounds. Each vehicle underwent comprehensive evaluation of its mechanical systems, manufacturing quality, and maintenance requirements. German engineers discovered that American tanks consistently operated longer between breakdowns than comparable German vehicles. The simplicity of American design translated into superior battlefield availability that more than compensated for any technical shortcomings. Unteroffizier Johann Richter, a veteran German tank mechanic assigned to evaluate captured American vehicles, found himself preferring to work on Shermans rather than German tanks. His maintenance reports consistently noted the ease of troubleshooting American mechanical systems compared to the complex, interdependent systems used in German tank design. Richter observed that Sherman repairs could be completed by crews with basic mechanical training, while German tanks required specialized expertise for even routine maintenance. The fuel system testing revealed another American advantage that German designers had overlooked. Sherman tanks featured multiple fuel tanks with crossover valves that allowed continued operation even when individual tanks were damaged. German tanks typically used single large fuel tanks that represented critical vulnerabilities when hit. The American approach provided redundancy that kept tanks operational, despite battle damage that would immobilize German vehicles. German test crews discovered that Sherman crews enjoyed significantly better working conditions than their German counterparts. The spacious interior allowed efficient crew operations, while the well-designed layout reduced fatigue during extended operations. German tank crews operated in cramped conditions that limited effectiveness during prolonged engagements. The American emphasis on crew comfort translated into superior tactical performance over time. The electrical system evaluation revealed sophisticated American design philosophy that prioritized reliability over complexity. Sherman tanks used simple, robust electrical components that could withstand battlefield conditions and be repaired using basic electrical knowledge. German tank electrical systems featured advanced technology that provided superior performance when functioning properly, but proved fragile under combat conditions and difficult to repair in the field. Communication equipment testing showed similar American priorities. Sherman radios were designed for ease of operation and field maintenance, with standardized components that could be quickly replaced or repaired. German radio systems provided superior range and clarity, but required specialized training to operate effectively and skilled technicians for maintenance. The American approach ensured reliable communication even with minimally trained crew members. Testing of captured Sherman variants revealed the adaptability of American tank design. The same basic chassis supported multiple configurations including standard tanks, tank destroyers, recovery vehicles, and artillery platforms. German tank production required separate assembly lines for different vehicle types, limiting manufacturing flexibility and parts commonality. The American modular approach provided strategic advantages in both production and field maintenance. The arrival of later Sherman models with improved armor and guns confirmed German suspicions about American upgrade capabilities. The basic Sherman design proved adaptable to significant improvements without requiring complete redesign. German tanks typically required entirely new designs to incorporate major improvements, leading to production delays and parts supply complications. The American approach allowed continuous improvement while maintaining manufacturing efficiency. German evaluation of Sherman crew training materials revealed another American advantage. American tank training emphasized mechanical knowledge and field maintenance, ensuring that all crew members could perform basic repairs. German tank training focused on tactical operations while leaving mechanical knowledge to specialized maintenance personnel. The American approach created self-sufficient crews that could maintain operational readiness without external support. Comparison testing between captured Shermans and German Panzer IVs revealed surprising results. While the Panzer IV possessed superior armor and firepower, the Sherman demonstrated better mechanical reliability and shorter repair times. In simulated extended operations, Shermans maintained higher operational readiness rates, despite facing simulated battle damage equivalent to that inflicted on German tanks. The testing of captured Sherman spare parts revealed the sophistication of American logistics planning. Every component was designed for rapid replacement using standard tools and minimal specialized knowledge. Part numbers were clearly marked and cross-referenced in detailed manuals that even inexperienced mechanics could follow. German tank parts required specialized knowledge for identification and installation, limiting repair capabilities to highly trained personnel. Field testing with captured Shermans in actual combat operations provided the most valuable intelligence about American tank design philosophy. German crews operating captured Shermans reported consistently higher operational availability compared to their experience with German tanks. The Shermans required less maintenance time and could be repaired more quickly when damaged, keeping them in action longer than equivalent German vehicles. Oberleutnant Friedrich Koch, commander of a captured Sherman during the Anzio campaign, reported that his American tank operated for 6 weeks without requiring major maintenance. His previous Panzer IV had required workshop time every 10 to 14 days for various mechanical problems. Koch noted that his crew performed all necessary maintenance on the Sherman using only tools carried in the tank, while his Panzer IV had required specialized equipment available only at maintenance depots. The combat performance of captured Shermans revealed the tactical implications of superior reliability. German units operating captured American tanks reported higher mission success rates due to improved vehicle availability. When German tanks broke down during operations, entire units might be forced to halt or leave vehicles behind. Sherman units could continue operations with minimal interruption, even when individual tanks required repairs. German intelligence analysis of captured American maintenance manuals revealed the systematic approach to reliability that underlay Sherman design. Every component was analyzed for failure modes and designed for rapid replacement or repair. Maintenance intervals were established based on extensive testing rather than theoretical calculations. The American approach treated mechanical reliability as a weapon system comparable in importance to armor or guns. The evaluation of American manufacturing techniques through examination of captured Shermans revealed production methods that German industry could not match. American factories used interchangeable parts manufactured to tolerances that allowed assembly without individual fitting. German production required hand-fitting of components by skilled craftsmen, limiting production rates and creating parts that were not interchangeable between vehicles. Testing of captured Sherman armor revealed American metallurgical practices that prioritized consistent quality over maximum hardness. German armor often achieved superior hardness, but suffered from quality variations that created weak spots. American armor provided predictable protection characteristics that could be relied upon during combat operations. The consistency of American production translated into reliable performance that commanders could count on. German evaluation of captured American crew equipment revealed attention to practical details that German designers had overlooked. Sherman crews received standardized tool kits that included everything necessary for field maintenance. German tank crews carried tools appropriate for their specific vehicle variant, creating supply complications and limiting repair capabilities. The American standardization approach simplified logistics while improving maintenance capabilities. The testing of captured Sherman variants throughout 1944 revealed the true extent of American production capabilities. Multiple improved models arrived with better armor, guns, and mechanical systems, while maintaining parts commonality with earlier versions. German tank development required years to implement comparable improvements, during which time American factories produced thousands of updated vehicles. Hauptmann Ernst Bauer, assigned to evaluate captured American equipment at the Berka testing facility, submitted a comprehensive report in September 1944, analyzing the strategic implications of American tank design philosophy. Bauer concluded that German emphasis on individual vehicle superiority was fundamentally flawed when facing an enemy that could maintain higher operational readiness through superior reliability and maintainability. The report noted that American tank units typically maintained 80 to 90% operational readiness rates compared to 60 to 70% for comparable German units. The difference resulted not from superior American manufacturing quality, but from design decisions that prioritized field maintainability over engineering sophistication. German tanks often possessed superior performance when functioning properly, but spent more time in repair status. Combat reports from German units operating captured Shermans consistently highlighted the psychological benefits of reliable equipment. Crews reported higher confidence levels when operating vehicles they could maintain themselves, rather than depending on specialized maintenance support. The reliability of American tanks reduced crew stress and improved tactical effectiveness during extended operations. German analysis of American tank crew casualty rates revealed another advantage of Sherman design philosophy. The American emphasis on crew safety and escape routes resulted in lower casualty rates per tank lost compared to German vehicles. German tanks provided better protection against penetration, but offered fewer escape options when disabled. The American approach balanced protection with survivability in ways that German designers had not considered. The evaluation of captured Sherman recovery and maintenance equipment revealed the systematic American approach to fleet management. Specialized recovery vehicles, maintenance trucks, and spare part systems were designed as integrated components of the tank force. German maintenance relied on improvised solutions and equipment adapted from other purposes, creating inefficiencies that reduced overall readiness rates. Testing of late-war Sherman models revealed continuous American improvements in reliability and maintainability. The M4A3E8 EZ8 variant incorporated lessons learned from earlier models while maintaining parts commonality and repair procedures. German late-war tanks typically required complete retraining of crews and maintenance personnel, reducing operational effectiveness during the transition period. German intelligence estimates of American tank production capabilities revealed the strategic implications of the reliability-focused design philosophy. American factories could produce Sherman tanks faster than German forces could destroy them, while maintaining sufficient spare parts production to keep the tank fleet operational. German tank production could not match American output while simultaneously providing adequate maintenance support. The discovery of American tank maintenance training materials revealed the democratization of mechanical knowledge that supported Sherman effectiveness. American training programs taught basic mechanical principles to all tank crew members, creating units that could maintain their equipment without specialized support. German training maintained strict separation between operational and maintenance personnel, limiting field repair capabilities. Analysis of captured American technical manuals revealed systematic documentation that enabled rapid training of replacement crew members and maintenance personnel. German technical documentation often required interpretation by experienced personnel, creating bottlenecks when training replacements. The American approach facilitated rapid expansion of armored forces while maintaining operational effectiveness. The testing of captured Sherman upgrades throughout 1945 revealed American adaptability that German forces could not match. Field modification kits allowed existing tanks to be upgraded with improved armor, guns, and equipment without returning to factories. German tanks typically required factory modification for significant upgrades, removing vehicles from service for extended periods. German post-war analysis of captured American tank design revealed the full extent of reliability advantages that had been overlooked during the conflict. Sherman tanks demonstrated operational availability rates that exceeded German vehicles by significant margins, providing American commanders with more usable combat power despite individual vehicle limitations. The American approach had revolutionized armored warfare through industrial engineering rather than military technology. The final German assessment of captured Sherman testing concluded that American tank design represented a paradigm shift in armored vehicle philosophy. While German engineers had focused on maximizing individual vehicle performance, American designers had optimized entire tank fleets for sustained combat operations. The difference between these approaches had proven decisive in determining the outcome of armored campaigns. Veteran German tank crews who operated captured Shermans consistently reported preference for American vehicles, despite their tactical limitations. The reliability and maintainability of Sherman tanks provided psychological benefits that outweighed the superior firepower and armor of German designs. German crews knew they could depend on Sherman tanks to function when needed, a confidence they could not maintain in their own vehicles. The captured Sherman testing program revealed that American industrial capacity had been applied to solve military problems in ways that German industry could not match. The integration of automotive mass production techniques with military requirements had created tank designs that prioritized availability over performance. German industry lacked both the capacity and the manufacturing philosophy necessary to compete with American production methods. Post-war interviews with German tank personnel consistently identified Sherman reliability as the most significant advantage of American armored forces. German crews reported that mechanical breakdowns caused more operational failures than enemy action, while American units maintained combat effectiveness through superior equipment reliability. The difference in maintenance philosophy had proven more important than differences in armor thickness or gun performance. The legacy of captured Sherman testing influenced German post-war military thinking about the relationship between reliability and combat effectiveness. German military analysts concluded that American success in armored warfare had resulted from understanding that availability was more important than capability. A tank that functioned consistently provided more military value than one that performed superbly when working, but spent significant time under repair. Modern military analysis of World War II armored operations has validated the German conclusions about Sherman reliability advantages. Computer simulations of armored campaigns consistently show that units with higher operational readiness rates achieve superior tactical results regardless of individual vehicle performance. The American emphasis on maintainability provided strategic advantages that more than compensated for tactical limitations. The story of War Daddy II and the hundreds of other Shermans tested by German forces revealed a fundamental truth about armored warfare that German military thinking had failed to grasp. Superior engineering meant nothing if tanks could not be maintained in the field. Sophisticated technology became a liability when it required specialized support that was unavailable during combat operations. The Americans had solved the puzzle of military mechanization through simplicity rather than complexity. At Kummersdorf Proving Grounds, where German engineers had confidently expected to confirm their technological superiority, captured Sherman tanks instead revealed the limitations of German design philosophy. The crude-looking American tanks outperformed sophisticated German vehicles in the most important metric of armored warfare: time spent in combat rather than in the repair shop. The Germans had built precision instruments while the Americans had built weapons of war. The captured Shermans, tested by German tank crews throughout World War II, demonstrated that reliability was indeed deadlier than armor. A tank that could fight every day was more valuable than one that could win any fight but spent half its time broken down. The Americans had understood this principle from the beginning, designing their tanks to fight a long war rather than perfect battles. By the time German forces realized this truth, American factories had already built 49,000 Sherman tanks, and German industry could never hope to match such numbers while maintaining their emphasis on engineering perfection over operational reliability.